Hi, welcome back. We're going to talk today about some code requirements, specifically for capacitor branch circuits or circuits supplying multiple capacitors or even single capacitors we'll touch on. So basically, what we're doing is a capacitor is a special device. We're going to use it for things like power factor correction, typically when we're talking a larger voltage type situation. So what I've got is capacitors being electrical equipment. We're based on section 26 of the Canadian Electrical Code. For our examples here, we're going to be using RW90 copper conductors at a 75-degree termination temperature. So we go in. There's a couple different important things that matter to us in this situation. What we're dealing with is we've got a single overcurrent device protecting this branch circuit, which is allowed to feed multiple capacitors. So that's Rule 26.208, Sub-Rule 2, where we're talking about multiple capacitors are allowed to be protected by that same overcurrent device. We've got a little bit of terminology that's important to us here. I'm going to call this conductor here my branch circuit. All right, so my branch circuit is supplying power to all of my conductors. And the other conductor that we're concerned about is this tap conductor over here. And the tap conductor is just supplying one of the capacitors. Then at the very end, we will discuss really quickly our overcurrent device. So when I'm looking at this and I'm talking about my branch circuit, my branch circuit conductor is supplying all three capacitors. So my branch circuit has to be at least 135% the rated current of everything that it's supplying. So if it's supplying three capacitors, and let's say that each capacitor is 21 amps. So this one's 21 amps, 21 amps, 21 amps. That would mean my total ampacity for this circuit would be 63 amps. So if my branch circuit carries 63 amps, I'm going to do that over here, branch. So my branch circuit, we say, is 63 amps. I'm going to take that number, multiply it by 135%. It's going to give me a number, which is 85.05 amps. I take my 85.05 amps, I take that to table 2. In this case, the 75-degree column. We're using the 75-degree column because, yes, it's a 90-degree conductor, but our weakest point is those termination points, and they're only rated for 75 degrees. So we go to the 75-degree column. We need a conductor good for at least 85.05. Can't quite get by on a number 4, so we end up with a number 3 AUG conductor, which is actually good for 100 amps. All right, so that's how we would size our branch circuit conductor. It's nothing too crazy. We just have to meet those requirements of that rule. Now as we get into sizing the tap conductor, we have a couple more requirements to meet. So we go into 26.208 sub-rule 2. It says where a conductor is, you are doing a tap conductor. They have to be a maximum of 7.5 meters long. So taps are max 7.5 meters. Okay? Let's say for our argument's sake here, they're less than 7.5 meters. They're 3 meters or whatever it is. Okay? So we are allowed to put a tap conductor. Then it says we have to meet the requirements of sub-rule 1, right? Which sub-rule 1 says you have to be at least 135% the rating of the capacitor. So 135% of, percent of the cap ampacity. Then it says and, meaning we have to meet all of the requirements, you have to be at least 1/3 the branch circuit conductor. 1/3 or the feeder conductor. 1/3 feeder ampacity. So those are the 3 requirements we have to meet. We have to be less than 7.5 meters. We have to be at least 135% the rating of the capacitor ampacity. And we have to be at least 1/3 the feeder ampacity. So in this case, we'll do this. We'll say we're less than 7.5 meters. Perfect. Now we will do our comparison. We'll take our 21 amps times 135%. That's going to give us a number of 28.75 amps. Awesome. Now, it also says we have to be at least 1/3 the feeder conductor or the branch circuit conductors. So, in this case, our branch circuit we determined was good for 100 amps. That's the allowable ampacity of that conductor. So we take our 100 amps, divided by 3, because we have to be at least 1/3, gives us 33.3 amps. Perfect. So the allowable ampacity of our branch circuit divided by 3, so we're at least 1/3. Now, the codebook says we have to meet both of those requirements because it uses the word this and this. So in this case, we need to take our larger of these two numbers, which is now going to become the required ampacity of our conductor. So in this case, I take 33.3. This, I don't care about it anymore. I take my 33.3 amps to table 2. Again, 75 degrees. Gives me a number 10 conductor. So that's how I would size my tap conductor for my capacitor. Now our very last step is I want to quickly discuss this overcurrent device. So the overcurrent device is a new rule. It's 26.210, just the rule right below. 26.210 says that the overcurrent device for a capacitor shall be set at a rating that does not exceed 250% the rating of the capacitor. So what we have to do, and that's our maximum overcurrent. We can always put a smaller one, but we cannot put one that is bigger than 250%. So in this case, we're going to talk about the maximum OC size that I would be permitted for code. So in this case, we know our load is 63 amps. So we can take our 63 amps, we're going to multiply it by 250%. 63 times 250 gives us 157.5 amps. Now, this would be the maximum current of our OC. This would be the biggest overcurrent device I could buy, would be 157.5 amps. If we were talking standard overcurrent devices, so this would be my max setting or rating, I guess. But if I was talking a standard overcurrent device, I would be going to table 13. Table 13 tells me my standard overcurrent devices. In this case, a 157.5 amp breaker fuse is not available. Because the rule says I cannot exceed 250%, that means I cannot choose one larger than this, which means in this case, I would end up with a 150 amp overcurrent device. That would be the largest breaker, standard rated overcurrent device that I would be allowed per code. I hope this was helpful. Thanks for watching.